make use of jQuery as opposed to using us. We can use it, and especially for AJAX and stuff like that. So we'll talk about it today a little bit. There we go. See, it's already recording. And let's get in there. We'll see how it goes with this part. I'll have a couple of parts to for this lesson for sure. All right, welcome back. We are Advanced Client-Side JavaScript. That's COMP2112 in the fall 2022 semester at Georgian College. And I see the faces here are bright and awake and early somehow. I don't know how. At 8 o'clock in the morning on a Monday, the day that Queen is being buried, right? So that's what's happening. And this week we're week 3 again. So let's talk about this. So last week we talked about our schedule, and I kind of said that, hey, we're doing a tool setup, and we did that all last week. I gave you guys a small in-class exercise to do, which I thought was really super easy. So you guys should have been able to hand that in or submit it. And hopefully you guys all did that. And that was due yesterday at midnight. Typically I get you guys to do things on Sundays. This week, so last week we did a bunch of tool setup, and we did specifically Git and GitHub, local install. We installed NVM and Node.js, but only just to help us with our downloading installation jobs, because like I said, I'm not going to get you guys to download anything by hand in this course, like go to the site, download the zip archive, install it, blah, blah, blah. That's old school. We don't do that, right? Typically. And so you're going to use NPM and Yarn, mostly Yarn, to do that kind of stuff. And so we did all that installation last week. We also talked really briefly, 2 slides about progressive enhancement, and you guys should know about the structure, kind of the layers of our model. That without content, there's no point having any kind of presentation. Without presentation, there's no point having any behavior, right? I mean, really, at the end of the day. Our JavaScript comes kind of last, and we have a person in the class that really loves CSS, and that's rare. But that's like, we need to understand how all that code goes together. CSS is a powerful tool, and most of us don't know how to use it very well, especially as developers. So we talked about that last week. We also did a very small demo on JavaScript and all that stuff. And today, so this week's agenda is slightly different. We're going to talk really briefly about ECMAScript 2015 and beyond. You guys know all this already, but I need to do a brief review because I need to connect your last class with this one a little bit. And for some of you who've been out of it for a bit, and haven't done JavaScript, we're going to move on to something else, but I want to talk about the highlights, and that's all I'm going to be talking about, the highlights of ECMAScript 2015 and beyond, what things you should know, as well as what AJAX is, also known as the asynchronous nature of JavaScript, right? And you guys should know about the asynchronous nature of JavaScript because it can mess you up, right? You think it's going to work one way, but actually it does not, right? So we'll talk about those things. I'm also going to give you just enough jQuery to make you dangerous, not much more than that. So jQuery makes AJAX easier is the topic. And then we'll do a small intro TypeScript, and we'll do our demo with TypeScript. I want to create a 5-page site, which is going to dovetail nicely into your assignment 1, because an assignment 1 I will release shortly. It's not quite ready. And again, please bear with me as I continue to roll out the content as much as I can. So that's really the plan for today. You have your in-class exercise that is already up, and it's going to be due on Sunday. But this week's in-class exercise will require you to make your repository private, not public. Last week, we said you can make it, public. It's okay. You're just getting started. This week, no. This week, you're going to make it private, and you need to include me as a collaborator. So I want to get you guys going with that stuff. It's not that difficult to do. But what it does is there's an extra step that I'm going to talk about today. And I wanted to do it in 2 steps because last week was enough, where some of you were just learning how to do command line Git, and other people were configuring their system. And I said, just give me anything that works. I'm good, right? This week is not like that. This week we're getting a little bit more serious. And I was just speaking to some of the students that were here earlier today, and this course ramps. Like next week, we're doing full CRUD with local storage, and we're talking model view controller design pattern, which you should already know from other classes. Example, ASP.NET. Rich, my friend, he's a very good friend of mine, and he and I worked very closely. We were talking about this course, and he's very excited for you guys to have all the stuff that we're going to be talking about this semester. So next semester, when you do his server-side JavaScript, which is all Node.js the entire time, he won't have to show you stuff that I'm going to show you. That's the idea behind this, right? So that's what he's doing. And then we're going to build our own little single page application by week 5. So there's a lot to do between now and then, right? A pile to do, right? Actually. And then in the second half of semester, we'll get right into React, right? So I can't get you to React yet. Yes, I can. Actually, I can. But, you know, the idea is I want you guys to understand the underpinning technologies that are available to us, which is AJAX, actually. AJAX is the technology that was used to create Angular and other frameworks out there. Without AJAX or asynchronous JavaScript of some kind, then we have issues when it comes to loading and all that kind of stuff. And I'll talk about why AJAX and those things in a second. So that's what our agenda is today. It's quite busy. I have 75 slides, right? And I don't want to go 75 slides deep. It's pretty deep. I'm probably going to skip. I don't like reading slides. I told you that last week. But they're there for you because you may need them for your midterm test, which is going to be basically a practical test that I will be giving you, very similar to what we've been doing in the in our assignments and in-class exercises. Okay, so again, just a review for the midterm test, which is kind of around the corner for us, believe it or not. And I'm talking about it as early as I can because there will be a week-long assignment that I'm going to give you. We officially will have class that week, but I don't expect you guys to show up, right? Only because it's going to be a take-home test. You do it at home, and I'm not going to give you any other content that week because it's going to be enough. So I'll be here for support throughout the week and all that kind of stuff. But it will be that'll be the one time if we're going to work remotely, like officially, that'll be the day. It'll be like week 7, right? So we can all do our thing. You can connect with me via Discord. Some people have tried to connect with me via Discord. I gave out the Discord server link last week. They did that on the weekend. And again, contact hours, 8 a.m. to 8 p.m., Monday to Friday. So if you try to connect with me on the weekend, I'm probably playing Dungeons and Dragons. I might be playing, you know, some tabletop role-playing game or something else like that. Or I might just be doing family stuff, right? And I'm not going to answer. That's just my decision. I just don't answer emails, and I actually have family time and stuff like that, as should you at some point. So I cut myself off Friday night, and then I'm just gone for the weekend, right? So when I come back, I look at my emails on Monday, and I look at my little messages on Discord, and then I start answering, right? So typically there's a 2-day delay. If you're giving something on Friday night and you expect something by Sunday, not going to happen. Just letting you know. Right, so straight up, I'm telling you that from an expectations perspective. Most of the week, though, I'm pretty good at responding. If I missed your message, I will get back to you. So bear with me as we roll. All right, let's talk about the first thing, which is ECMAScript 2015 and beyond. You guys should know this stuff, right? So I want to do a brief review. So 2015, the world changed. JavaScript changed. It actually became a lot better than what we had in ECMAScript, you know, earlier versions. And I have to tell you this because ECMAScript 5, right, before that was actually a pretty good version of JavaScript, right, to be honest. And it was the 5th edition of ECMAScript 5, right? And that's why it was named that way. It was actually 5, 6, 7. That's why it was called ES6, right? ECMAScript 5 was, you know, kind of was bundled along HTML4, right? Believe it or not. And CSS3 was out already, but not fully in force until 2015, when everything kind of came together. CSS3 came out and was really mainstream at that point. You know, suddenly ECMAScript or JavaScript, which is what ECMAScript is, the kind of the foundation for JavaScript, suddenly had classes that were not prototype based. It wasn't prototypal inheritance. You could actually look, it looks like that you were doing classical inheritance. But guys, don't be fooled by this, because JavaScript is still prototypal inheritance underneath the hood, right? So, you know, did you guys do any of that old, you know, class stuff? Like the old way of doing classes, not the new way with just the word class. Yes? You can't remember, right? It's ugly, is what I'm saying, right? It's really ugly. And I'll show you it a little bit today so you see it. You're going to see some of this stuff. I always think about it as what's out there in the wild, right? In the wild, when you work for a client, you're going to see all kinds of stuff, right? You know, frameworks, like we talked about earlier today with some of our students, where it's a mess, right? You're looking at it and it's some kind of code generation algorithm that's pumped out some kind of code, and you got to understand the code base. Or just delete it, you know, or just make your own. So, so I think, you know, there's a lot of stuff out there, and that's why I want to talk about some of this stuff as we move forward. Not too much, but just enough to, like I said, for you to have an understanding. Right now, we're sitting at ECMAScript 2022. Okay, officially, it was released this June, if I'm not wrong, right? So every June actually is where they release their latest version of ECMAScript. And it always comes with some new features. Some of them you probably won't use at the beginning, but they continue to roll out new things because there's such a demand for that kind of thing. One of the things they came out with this 2015 was the module pattern. There's two module patterns we're concerned with. One of them is the CommonJS or CJS module pattern. And then there's the ECMAScript module pattern, right? Which is the one we want to care about. ECMAScript module pattern, which is uses import and exports a lot more times, is the stuff that we want to do with Node.js on the back end more than anything else. Module patterns, in my opinion, are something that JavaScript still doesn't get right 100%. And let me tell you why. There is no namespace in JavaScript. It doesn't exist, right? You have to create your own namespaces, which is where TypeScript comes in. And we're going to talk about TypeScript, how it adds really great functionality even now. And we'll talk about why TypeScript. But you can create a module. And a lot of times what we want to do in this course is split our files across, or split our classes across different files. We don't want to use one file to have all your JavaScript. So if you're used to doing that in the last class, yeah, no, we're not doing that. We're splitting our files. We're going to have multiple JavaScript files this semester. And so you get really used to, you know, kind of developing that way. They kind of look like this, modules. You should know about this. I have a function. And again, I have to set it up by the way, at the bottom of your HTML file or in your, when I kind of do my script, I go script source, and then type is equal to module. And once I do type is equal to module, I enable it. Now, warning, if I do this, type is equal to module, compatibility, you know, suddenly drops, you know, from one browser to the other. I always kind of look at things like, can I use? I'm not sure if you ever see that site. Maybe you have. Hopefully you have, right? So can I use.com? And if I look at something like module in can I use, then you're going to see that, you know, most of the browsers nowadays have support, you know, for you know, modules and so on. So here's JavaScript modules via script tag, right? So this is what I'm talking about. And you can see that still around 96% of browsers are supported. There are some that are not, especially older browsers. And that means that when you go back to kind of a, I don't know, if you're going to a client and they use some internal, you know, of their own little websites or whatever, and you try and use a module that, and they might have some old browser. Some people still do this kind of stuff. They don't upgrade their machines because, you know, they want to take advantage. They want to squeeze out as much as they can from their old machines, and they don't want to upgrade because of security concerns and so on. So this is not going to be 100% compatible, but it's there and it does work. And it kind of looks like this. Like I said, scripts type is equal to module. So that's the way it would work. And then you can do your exports and imports. So let's suppose you have a lib.js and you want to export some kind of half of function. The half of function is actually going to return half of whatever the value you pass in as a parameter, right? And then if you import the half of function from lib, notice that we don't put in the .js at the end, right? Then what it does is, and this is where things get funky, and I'll say it like this, it actually creates a reference to the whole object. So it's an object reference, rather than it importing the whole module. It's not injection. It's not code injection, okay? So normally when we do imports in other languages, let's suppose I'm doing it with C++ or C# or something like that. C++ uses imports, C# uses usings as an example, right? However, we import the module or even Java, right? We inject that code where we import it, right? Not so here. That's not the way it's done. Actually, what we're doing is we're creating a reference, that represents the entire module in one identifier, one variable. So example here, where I say import half of from lib, half of represents this from the other module, right? But remember that this is just one function. I could have multiple functions in a module, right? And this whatever variable that you're going to assign it to can represent all of them, which is kind of a different thing. It's almost like it represents the module object itself, not necessarily one function, which is something difficult for people to get sometimes until you start using it. We'll do it this semester. Don't worry. I'm bringing it up just so that you see it. This is one of the features that ECMAScript 2015 talked about. And so it shows you some examples here of how you can use them and so on. The other thing that they had was the default export. Default export, what it'll do is, if you say that I want to export to default, that means that this function, whatever it's called, is the default reference that I want to export. Notice that this is an anonymous function. There is no name for this function. And when I do export default, when I import it, then do something represents a reference to this anonymous function. Okay, questions right there. Does anyone feel uncomfortable with what I just said? Yes. Do something is the name of the file, right? Do something here is the name of the of your identifier, your variable that you've decided. You can decide to call it anything you want, right? And what you're doing is when you import do something, because the file itself called do something.js has the export default, you don't need to name the function. Remember, what are the three ways we can create functions in JavaScript? There's three ways right now, not one. I could have a named function, right? I could call it like, Tom, and then parentheses, right? The function Tom, right? And then that's one way of doing it. I can also say, let Tom equals to an anonymous function. I could do that too. And the third way is, I could use an arrow function, right? Those are the three ways. You guys have learned arrow functions last semester? Yes? I'm putting my hand up there like the Queen used to put it up, like, one of these, right? So yeah, the problem with it's just understanding how functions work. So functions actually, we'll talk about that today. Since you brought it up, I'll do a demo on what functions are, and I'll kind of hook back to this. In fact, why don't we do a bit of both, right, to start going. So on that, because you guys, and thank you for that, because that gives me, that kind of gauges my knowing how what you know. Let's bring up our stuff from last week. So I'll stop right there, and then we'll do kind of an interactive demo as opposed to me waiting to the end, because you need it. So I'm going to go into last week. Last week we had this week 2 folder, and what I want to do right now is I want to copy and paste that week folder into week 3. Now there's not much in there except for node modules, but you can see that node modules take up a pile of files, like 5,000 files, right? And we did like literally nothing with them last semester, like last week. We did nothing with the node modules folder, right? So you can see that it takes a long time. Alternatively, if we didn't do this, right? Let's cancel this. I want to show you something else. Okay, so this definitely I can do this. Look how long it takes, right? And this takes really, really long. Even when I have an SSD, right? I have 32 gigs of RAM. I'm on, whatever. I have a fast computer. I have an i9, right? It's not like it's a small, whatever, but it takes a pile of time. Why? Every file that I'm copying over is being indexed, right? And that's really crap-a-load, right? I'm going to let it do its job, but then I'm just going to erase it and try it again. Let's try it again a different way. So I'm just going to erase this thing. So goodbye. I don't care about that. And even erasing takes time, right? But here's what I want to do. So if I go back into my old week 2, let's go back into my week 2 folder, right? And let's delete the node modules folder. So if I delete this, so I'm going to go shift delete, please, shift delete, so I get rid of it. And then if I try and do a copy, so if I do a copy from week 2 to week 3, watch this now. So I'm doing a copy and we're done. Like it's going to be like, compared to before, it shouldn't be like, a crazy amount of work, right? Compared to last time. Because if I go down here, now we don't have node modules. What took a long time was the hidden.git folder. Because not only does the node modules have a lot of files, but so does the hidden.git folder. The hidden.git folder, because we included node modules, also includes a copy of node modules, right? That's how it works, right? Because remember what we're doing with Git is we're getting a snapshot and we're getting a baseline for all of our files, which means they have to copy everything, including all the node modules, right? So that we're double copying them when we do it this way. So now you can see that my week 2 copy, which I'm going to call obviously week 3, let's do that together, is going to be the one that I want to do. I want to pull in this into Visual Studio Code. So let's bring up our Visual Studio Code from last day. And what I want to do is, again, I want to take this week 3 and drag and drop it into Visual Studio Code, which is going to update my folder into week 3. So this is week 3 now. A couple things to note. Here's some things to note for you. This is a non-functional project. And remember, we talked about last time in our package.json, there are 2 parts to it. We have a set of dependencies, and I talked about 2 dependencies. I have dependencies and dev dependencies, project dependencies and dev dependencies. I asked you, I was going to do this last week. Can anyone tell me what the difference between project dependencies and dev dependencies are? Yes. 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 Project dependencies. Yes. Wonderful. That's also good. So what both of you said is absolutely correct, right? So I don't need dev dependencies. I need project dependencies. And here, because I have just dependencies listed, I need them all, but I don't have any of them, right? Before I add them in, as you can see, there's like 2,000 updates and so on, right? I want to add something called a gitignore file. Let's do that now. So I'm going to go here to the file, and I'm going to add in something called a .gitignore file. And in my gitignore file, I want to list node modules. Okay, so I want to save that. That's all I'm putting in my gitignore file, just node modules, right? And what this means is, if I add node modules folder to my Git repository, it should ignore it. However, we had it before, yeah? We had a node modules folder when we first made our Git repository. And because we copied everything from week 2, last week to this week, we have that hidden folder copied over too. So can anyone tell me what the problem with copying over the old folder is, that old .git folder? What does it do? It doesn't just take a baseline. There's something else that it does too. Yes, we want to keep those. We want to keep our commits and changes, but what do we not want to keep? There's something we don't want to keep with that Git thing. Yes. No, we want to keep those. We want to keep all that stuff so we can backtrack, right? But there's something we don't want to keep that is in our .git folder. Yeah. Yeah, that's exactly right. I don't want to keep pointing this to my old repository. I want to point it to my new repository. And that means that we need to remove the remote. Okay, let me say that again. We need to remove the remote. The remote is just a file, reference to the repository. It's almost like I'm pointing to it. I'm saying, okay, I want to point to that remote, right? And now I want to point to another remote. In order for me to do that, I need to remove the current pointer to that remote, and I need to repoint it somewhere else. Here are the commands for that. Let's do that together. Before we do any kind of other thing with this project. Again, control backtick will bring up the terminal window. We'll clear the screen, right? And I will put in, let's look at the remote. So if I do git remote, and I do -v for verbose, right? And if I press enter, it's going to show you the target of our project, right? Our target remote is this repository up on our, our GitHub. But this is last week's. I don't want last week's. I want this week's, right? We haven't even made a repository this week yet, right? So I want to remove this. I want to say, here's the way you remove it. Git remote remove rm origin, because it's called origin. Look, here's the name right here, origin, right? By the way, you can name your remote connection anything you want. Conventionally, by convention, we call it origin, right? But you can call it GitHub. You can call it Tom. You can call it whatever you want. And sometimes we do because we have more than one remote. Example, I have a staging site, right, for my client, and I have a production site for my client. I do everything on the staging site, which is linked to my staging repository. So maybe I'll call my repository remote staging, right? So if I do git push staging, it pushes to the staging site, and then it automatically updates, which I'll talk about how that works, right? Or I can go git push production, and then it'll push to the production site, and the production site will actually update. You don't want to do that, right? You want to do it only when you're absolutely sure you can cut over, right? And it's actually a lot better to actually have two and then just go swap, right? That's a little better. So then you keep your old stuff, so you can always swap back. You don't want to overwrite the old stuff. That would be bad. When we talk about cutting over, and I'm telling you this, I'm just giving you some advice. If you're working with a client, right, you always want to keep their old site, because the changes you think are going to work, and if you cut over and then things don't work, you can always go, let's swap back. It's just not working tonight. And we'll just work on it and figure out the problems, and then we'll swap over. Because if you swap, if you do a destructive push to their live site, getting it back is really hard, right? So here it is. This is the command. If I do this, I press enter, it removes the remote. And if I do the same the command earlier, like git remote -v, now there's nothing, right? You can see that I've removed it and I'm here. I need to add a new remote. And in order for me to do that, I'm going to go up online and I'm going to go to my repository. You can go to yours. So here I'm going to go to github.com/Georgian College, because that's the organization that I control up on GitHub. And then if I click new, or I press the plus on the top right, I can create a new repository. Now for this repository, because this is going to represent your in-class exercise 2, you need to keep it private. I'm keeping it public, but you need to keep it private, okay? Actually, what I'll do is, for now, I'll keep it private too, and I'll show you how to change it both ways, okay? So I'll keep it private, and then I will change my remote repository name to COMP2112 and fall 2022 semester, and it's week 3. Yours will be ICE2, right? Because you're going to submit your ICE2. That's all I need here. I'm not going to add anything else. I'm going to click create repository, and it's going to give me steering instructions on what to do. I've already got all of this because I had my previous commits from last week, remember, right? All I need to do is issue these 3 commands again, one more time. Actually, you don't even need all of them, but I'm going to anyway. I'm going to copy this little thing right here. And when I copy it and I go back into my Visual Studio Code, and if I just right click here, it just pastes it in with the new remote information. If I press enter, it's going to push everything up to my new repository. One thing to note is that if you've never done this before, or if you didn't configure your stuff properly last day, like somehow you didn't log in and you didn't save your information or something like that, it may ask you to log into GitHub again, okay? If you've done it one time though, and if you did it like me, it would never ask you again, right? Unless there's some kind of weird mess up with your configuration. Okay, so at this point here, what you should see is, if you did everything the same, right? If you refresh, you should see that the new repository is looking like this, right? And are you with me? Yeah, that's why I'm asking that question.
Did you copy this?
Just this part. So I can't go back, but it's the last 3 lines of code. So as soon as, it says like, there's a big area that says, do this if you have a terminal, and there's like these 3 lines by itself. Those last three lines of code is the things that you need to update your Git repository. Again, it's been recorded. So worst case scenario, guys, you can go back and take a look at this. All right, now let's take a look at something else. If I go back here to GitHub or to my Git repository locally, and if I do something like, let's clear the screen. If I do git remote -v now, I can see clearly that my remote is pointing to a new repository, week 3, not week 2. This is what we need to do every single week, okay? And yes, I could get you to make one big repository for all your in-class exercises, but it's not going to give you enough practice for what I need you guys to do, right? So this way, when you're working with Rich, for ASP.NET, or next semester, when you're working with him for server-side scripting, you'll be well versed on how to do all this stuff, and it won't even be a tick, for you at all. All right, so now that we've done this and we've put this up on GitHub, we still have this thing over here. Visual Studio Code is saying, hey, there's 2,000 changes you need to make because we've removed all the node modules and we've added a git ignore file. Let's add a new commit. So here's our new commit. We're going to say git add dot. That's the first thing. Anytime we do this, it says warning in the working copy of yarn error log, blah, blah, blah. Who cares? That's the first thing. And then when you're going to do a git commit -m, and we'll say added project files for, in my case, week 3, in your case, ICE2. Added project files for week 3. When I do that, you're going to see it deletes all the node modules. And notice that my little symbol on the left here in Visual Studio Code goes away. There's no 2,000 files waiting for it to be updated. Okay, yes? I'm going there. That's okay. Okay, I can't go there. So sometimes remember that the command is only here. It looks like this. This is the command. This is the command. Git commit -m, added project files for week 3. You might say something like git commit -m. -m is what's the message? That's what -m is, right? All right, now that I've got a commit, right? I can push this up to GitHub again, right? Because I already did a commit. So what I can do now is, I'm just going to clear the screen here, is I can do another push. I can do git push, right? When I do that, it's going to push up to my new remote, which is the one I just made on week 3. And it actually tells you where it's pushing. Take a look. It says, here's the remote resolving deltas. Deltas means changes. That's what deltas mean. And then here's the new remote that it's going to, week 3, right? And if I look up online and I refresh, you can see that now I have 3 commits, right? 2 from last week, 1 from this week, right? Because I just did a push to the new repository. Again, are you with me? Awesome. I'm going slow here because, this is where people miss a step and then they're like, what happened? How did you do it? But we made a private repository and you need to include me as a collaborator. Now I'm going to get a pile of emails saying things like, this person has added you as a collaborator. Do you accept? The acceptance for a collaborator lasts for 1 week. If I don't accept in the week that you invite me, I can't access your Git repository. You need to re-invite me. All right. So I try and kind of accept as soon as I get them, right? The same day or the next day. This is what you need to do. You please go to settings for your Git repository. And I want you to go on the left where it says collaborators and teams on the left. After you go to settings, click on that, please. And when you go to collaborators and teams, you will have to potentially log in. I need to do 2-factor because that's just the way I am. You should also set up your 2-factor authentication because your Git repository, well, it's all about you. And if anything happens and someone, you know, kind of hacks your repository, you would not be happy with that. Like example, deleting all your repositories, right? People do that kind of stuff, right? Because they can. So if you haven't turned on two-factor, you don't have to do it right now, but I recommend it. Right, this way, if you make a mistake and you put your, you know, whatever, you show your password somewhere, who cares? Because you got two-factor, right? All right, so now we're in here, and notice it says here, it's a private repository, and only those that have access. Here's my base role. Here's direct access, and down here it says add people. Right, there's two options: add people and add teams for me. I'm going to add people. So if I click add people, you can search for me, and it's my last name at hotmail.com. So that means, let me spell it for you, TSILIOPOULOS. Notice that there are two of me. There's actually a third person somewhere, you know, probably in Greece. But I'm the only Tom Tsiopoulos in Canada, right? And probably in the United States and anywhere on GitHub. But I have two of me. How's that possible? Well, because I actually do business outside of teaching, right? So, so the second one where you see Tom Tsiopoulos, where it says, you know, this Tom Tsiopoulos like this, that's not me. Don't use that one for our school. Use this one, the first one. And the way to verify that is if you actually put in at hotmail.com, right? Then it'll just filter it to only one dude, this dude right here, this version of Tom, right? The other clone of Tom that works somewhere else and does other things, you don't want to send him anything, right? Because he's not going to accept it anyway. All right, so this is the one. And then you can select the member above, and then you can give that member, I only need read access, guys. I don't need you to make me an admin. Making me an admin allows me to mess with your files and do that kind of stuff. Why would you need to do that? Just give me read access. That's good enough. Yes. This? If you don't see it, I'm saying, if you, I mean, if you don't have this, that's good. Doesn't matter. I'm just going to get read access, you know, kind of thing, unless you otherwise tell me otherwise. So as long as you do that and you press add, then what's going to happen is I'm going to get a pile of emails now from you guys. Basically, here it is. Here they come. Right, here we go. Nicole, I got yours. Right, and that's how fast it is. Right, so it will be like coming down the pipe for me in terms of getting all these things. Please do so. I'm okay with that. And now that we're doing it together, you know, this is the process. I'm stepping through the process with you so you understand how to do private repositories for both your in-class exercises going forward, as well as for all of your assignments and your tests. All right, so everything's going to be private here on in, right? So that's what's required. I will check to see if the repository is private when you send it over to me, right? This way, it prevents people from doing things like, oh, I want to copy, you know, Tom's repository, you know, whoever Tom is, right? Or I want to copy Nicole's repository or somebody else, right? I don't want that. Or Tyler's repository, you know, as an example. You know, they can't copy your stuff. They can't fork you. Right, and that's another thing that they can do on GitHub. They can fork you on GitHub, and actually it sounds funny, and it kind of is exactly what it sounds like, right? So, so please be careful because people can do it anytime they want. When you want to keep your code private, always keep a private repository. And on that topic, if we ever do something like SendGrid, any APIs that use any kind of email relay, or anything else that requires your password or API or whatever, you keep that your repository private forever. Because if you expose that repository, make it public, SendGrid within 2 seconds will shut you down. You'll not have email relay at all, right? I'm saying SendGrid because it's a very popular email relay service, right? So example, you want to make a form that sends email to your client when someone does that kind of stuff, it will break immediately if you make your repository public. Keep it private from now on, all right? This way you can do whatever you want. Other ways to do that is to actually keep your APIs in an environment variable on the server somewhere. That is even better, so that you don't even have it inside of your application. And we'll talk about that as we get towards the end of the semester, right? But yeah, now what about if you wanted to make it public? What do I do? And I see there's a question here or something. What was that? Oh, is that what it is? I added Tom with Hotmail. I am right. Yes, you are right. So yeah, it's this one. It's just to put it up on Zoom. It's tsiopoulos@hotmail.com. That's the one. All right. So so if I want to make this thing public somehow, how do I do that? So again, under settings, if I click on settings, again, if I scroll down, way down here, there's a danger zone. And I kind of talked about this briefly last week. One thing you can do in the danger zone is change the visibility. The other thing you can do in the danger zone is delete this repository. So if I wanted to delete the repository or whatever, or if I made a repository that wasn't formed properly or whatever, I can do it here. Other things to do is, if you've never shared a repository, you can always change the name of your repository up here. So that's something you can always do. You can always change the name of your repository. However, warning, if you change the name of your repository, all of your links to the repository, including your remotes, will fail, right? So because it's the name of your repository is the link to your repository. So please be careful about that. So you can change the name, no problem. But down here, I want to change the visibility. I want to make mine public. What if you wanted to do this? So first you start off with private and you wanted to make it public because you're sharing something in the community or you're teaching a course, right? I'm going to click change visibility. And it's going to say, what do I want to do? Make it from private to public. By the way, it goes the other way too. If you accidentally made it public and you need to make it private, you can do it the same way. And then what you need to do is copy and paste the name of your repository and your account name if you're going to change the visibility here. And then it's going to ask you to sometimes to log in and to make those changes. Now, if you look at the top here beside my repository, it says public, not private. You should have access to it at this point. And if I was going to share it with you, and I'll share it on Zoom, for those people that have it. Here it is. That's my new repository. And you can see that that is going to be the public repository that I'm going to be using for today. All right. So public, private repositories, we talked about that. And I talked about how to repoint your remote to the new repository from the old one. Why? So we can keep our commits, right? Sometimes what I like to do is I want to have the exact same project files and I make a whole brand new repository. I don't continue the old one. You know why? I want to do some experiments. I want to experiment with my stuff, and I don't want to mess up my code at all. My code's working. Why would I break my build, right? So what I'm doing instead is I make a whole brand new repository. It's my experiment. If I mess it up, who cares, right? It's just my experimentation, right? I have a lot of little experiments like this, right? And that I kind of put together because I want to test stuff out, right? Without affecting the client, without affecting my code base, without affecting my project work, my research, whatever, all that kind of stuff. It's a brand new repository. For us, we're going to make brand new repositories every time for this semester. It's going to make my life a little bit hell because I'm going to get your emails every single week, probably every Monday, right? As we do it. And then I'll answer all your emails. I can click onto them and I'll say yes, 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 yes. But it's okay. It's only one time. All right, great. So we've made our repository public and I've also taught you about how to make it private. And now what we want to do is because we're missing our dependencies, we don't have our dependencies, right? I'm going to use Yarn to put them back in. The way you do that is you issue a Yarn install. And what Yarn install does is it downloads everything here. And it's way faster than you copying your files over, as you can see. It's done. Way faster than actually copying it from your hard drive to your hard drive. Why? Because you don't have to index anything. When I'm doing a copy from one side to the other, your hard drive does all this validation and stuff like this. There's no validation. So it's actually faster to download your projects, your dependencies from the internet than from you to actually like copy it from your computer to your computer. That's why you remove node modules when you go from week 1 to week 2, from week 2 to week 3, and so on. You don't do that because it's going to regenerate them anyway, right? It will be a lot faster, right? It'll be a lot faster. Absolutely. Yep. Sometimes though, we'll need the node modules and we'll talk about when we need them, right? And if I need them, I'll put them back, right? So don't worry about that. For now, notice that in our Visual Studio Code, our node modules are dimmed out. When I call these things dimmed out, I mean they're grayed out. Everything else is nice and bright. You can see that they're white colors, but here in my node modules, it's kind of a gray color. If you see this, right, as an example, then you know that your node modules are being ignored. I have a git ignore file. Here's my git ignore file with node modules in it, and it's ignored my node modules. Okay. All right. So now that we've done for this part, let's go back to what I was talking about. Let's go to my scripts folder and in my app.js. And in my app.js, I wanted to talk about the 3 ways you can do functions. Here's way 1, right? So here's first way of, or let's say call it method. First method of using, functions. right? This is the first way. We have the keyword function, right? And then we have the name of the function. This is called a named function, a named function. And although you guys might like it, it's not the most popular way, right? Here's the other way. I'm going to comment this one out, all right? Let's comment it out. And by the way, again, shortcuts, when it comes to block comments, you can do it here. Line comments, control /, right, is the way to kind of comment it all out. And you can toggle that on and off. So here's the second way. So second method of using functions. I want to do the exact same function. I'm going to use the keyword let, and then I'm going to say the name of the function, start, and it's going to equal to an anonymous function. And then I'm going to take this console log here and paste it in. Okay. And most of you will look at this and go, I hate it. I don't like it. Huge. One, my start method, right? Or my start function, there's no difference functionally, but there is a difference in how we write this and how it's used. So, and the reason for this is because here, this function start, as an example, that I've made it this way. I want you to understand the difference. What we're actually doing when we develop this way, we do it this way, is we're saying, I want to point my start. If I hover over, I want to point my start variable to a function. It's actually a functional pointer. That's what it is. And just to draw this out for you guys, right? It's like this points to this. That's what it does. It kind of says, hey, I'm this variable name. I'm pointing to this right here. That's what it is. And this function, it's an anonymous function, right? Anonymous means there's no name for it. And this is the part right here. This is that part of the function. This is it. This is that function, right? So this function here, right, is something I can write. I can write anonymous functions, right? Or we also call them inline functions, right? That's what they're also called. Inline functions or anonymous functions. So this is method 2. Method 2 is writing this way. And I'll tell you, this is more popular than this way, believe it or not, even though I like this way a lot, right? Because it reminds me of C#, C++, Java, and other languages. It's not the most popular way that you're going to see online, okay? So that's why I'm mentioning it to you. So this is function form 2. And let me just clear that up. Function form 3. It's an advanced form of the function. So let's actually what I'll do in this case, notice that there's a little light bulb here next to me. Whenever you see a little light bulb next to your function and in Visual Studio Code, it's going to say something like convert to named, convert to arrow. Those are the 3, right? Here's my arrow function. But instead of converting to arrow, I'm just going to take all this, copy and paste it first, right? And I'm just going to comment this part out. So you can see this is the second way. Right, so here's toggle. And this is the third way. So it's an arrow function. And the way it works when I convert it, it looks like this. This is why the let is the more popular way. Because then we can convert our functions to an arrow function. And arrow functions are very different than every other function. Okay. Review for you guys. What makes arrow functions different than a regular function at all? Do you know the difference? Have you studied arrow functions at all? A little bit. Do you have anyone have an idea what they are? What's the difference? So I have a chat comment here. What did I do before the function on the menu? I didn't do anything. I just all I did was I commented out. That's all I did. All right. Okay, let's go over the first one. So the first one, right, what it is there is something called the application context, right? And the application context, and I also like to think about this as the browser buffer, right, has a this, right? The lexical this, right, when you think about that. And this refers to the function itself, the browser, the actual namespace itself. If I use the keyword this, right, as an example, it refers to this namespace because guess what I've done? I've created a closure with my IFI. Last week, we talked about an IFI. And what an IFI does is it encloses it's almost like I put my functions in jail, right? That's what I do. And it doesn't allow variable names and those kind of things to escape into the global namespace. I don't want that, right? It's like making a global variable or a global function. I want to encapsulate that, put it in a capsule or an envelope, right? And I only want to expose the functions that on purpose. I want to do it on purpose. I don't want to do it by accident. And I definitely don't want to let my variables and functions run wild, right? Because they could clash, with other, maybe I have multiple functions named the same thing, but I could, right? Across different files, but I want them to be encapsulated in different namespaces so I can do whatever I want, right? So the keyword this refers to, in this case, this function right here, from here to here, right? If I use the keyword this in an event handler though, what does the keyword this refer to? Does the keyword this refer to the closure, or does the keyword this refer to the event handler? Example, this is an event handler, right? I can write this event handler in two ways. I can write it like this, right? This event listener, right? There's two parts, right? When we do JavaScript is event driven. I have a listener, which I'm listening for an event to trigger, right? In this case, I'm listening for the load event of the page to trigger. When the page finishes loading, this is what this is saying. Call my start function, whatever that is. That's what this does when the page finishes loading, okay? So we're talking about events really quickly. I could write this. This is one way of writing it. And I'm just going to comment this out here for, actually, I won't comment it out. I could just write it here like this inline. I could say function, right? And I could write the function like this. This is an inline way of doing it. And I'll do a console log, right? Like that we did before, app started. I could write it this way too. I don't have to use a function at all like this. Notice now it went dim. My function went from nice and bright white to dim, which means this function here is not even being called, right? I'm writing it inline. If I write it like this, this keyword that I use inside of my event handler is only referencing the event handler itself. However, if I write it as a arrow function, which you can write it like this, here's the arrow function method. If I write it like this with a fat arrow, is what we usually call it, fat arrow function. If I write it like this, the lexical this for the entire namespace is preserved. That's the difference, which means I can carry forward the this that represents this whole namespace as opposed to the this that only represents this little function piece. That's confusing, right? If you've never done it before, right? Because here in JavaScript, we have a function within a function within a function within a function, but sometimes we call that functional hell, right? So, but that's how it is. I want you to think of every function as its own closure. Every function is its own little container, if you will, right? And when I make a function with an arrow function like this, it passes in, it's almost like opening the doors of that container to the bigger container. That's what it is. If I use the other way, if I went from an arrow function, if I went to a function that looks like this, right, which is the old way, this is the old function. Sometimes we want to use this way because it closes the doors to the greater container, right? In other words, if I use the lexical this in this case, it's inside of the function itself. It means if I use this in this function, it refers to this function right here, right? That's what this does, okay? And that's the difference between the three. You got it, right? And this is some of the most confusing part for a student. So 3 ways of making a function, 3 ways, right? Name function, the old way with the anonymous function, or anonymous function that is an arrow function, right? And arrow functions and anonymous functions have their uses, right? One passes in the this from the greater container, the other one does not. And sometimes we don't want to do this, okay? I can always go back and forth, however. Let's go back to my original one. I'm just going to comment this out. And I want to uncomment this piece. So here it is. Actually, let's do the other one. I want this one. I want this one, right? And this one I want to call start. That's how we had it, kind of had it here like this. We kind of had start here. And this way, notice that start lights up, right? Light start is connected. But I wanted to put it in here so you understand the three, right? If you've never done this kind of functional stuff before, this is kind of our basis because JavaScript, everything is an object for the most part in JavaScript, right? And functions are its foundation. Without the functions, we can't do anything, right? Remember, with functions, we can create classes the old way, right? Whereas without functions, we cannot. All right, let's move on. Any questions around functions and the three methods that we can use? There's three ways. And by the way, functionality wise, sorry to no pun intended, when it comes to, if you don't care about the lexical this, you don't care about this keyword. They'll all do app started the exact same way. They'll appear to work identically, right? Functionally, they won't work differently. One thing is what we want to do is at the top of our code, right? To make our code even more strict, I like to use the use strict directive. Please put that at the top of your code from now on. The use strict directive is something that you all should be using from day one when you code. The reason for this is it will not allow you to use things like or declare variables, right? Or use a variable without declaring it. Before, if you don't use strict, you can use a variable and never declare it. JavaScript is funny. It's a funny language. Some people love it and some people hate it. And one of the reasons people hate it is because it allows you to do funny things like that. Other rules we're going to use in this course. Remember, I talked about this last week. The word var is banned from this course. If I see var in any of your code, I will not mark it. I'm serious. You cannot use var in your code at all in my course, at all. If you use var, VAR, right? Yeah, please don't use var ever in your code in my course, right? First of all, it's old. We don't use it, and there's no need for it. We have let and const. Let is very similar to var, but better, because why is var bad? You guys should know this already. Neither does let, right? Why is var bad? Super bad. It's like not the movie Super Bad. Bad. It's really bad. var allows it kind of promotes something called hoisting. You guys ever hear about hoisting? If I declare a variable in my code, right? The way JavaScript deals with it was, remember, the browser it parses your code, right? So as the browser goes through line by line on your code, it goes through any var declarations, right? And what it does with var declarations is it goes, oh, I need to put this at the top, right? So it hoists. That's what hoisting is. It takes your declaration and in the background rewrites where you put your var to the top of your code, right? And here's a negative side effect. Let's try this out. Let's try var for a second. First and only time we can use it, okay? Just for an example. If I do a for loop, right? Here's a for loop, and I'm going to use var, right? And instead of using, you just go like this. You just type in for, and then there's right here. It comes up with a little menu, and you choose this one. Look. Right, and you want to change this from let to var. Look, it even gives you let because it doesn't want you to use var, but you want to make var. We're going to check var out. All right, so what it does is if I do something like index 0 and I want to console log index, right? Then you should get in the console, you should get a number between 0 and 9, right? Or 0 and let's go to 10, right? So we'll say from 0 to 10, which means it'll output 0 to 9, right? In the console. And let's test this out. I'm going to do control backtick, and let's use our thing we added in last day, light server. Remember light server? Let's call light server, so light-server. And when we do light server, it brings up our default browser. It launched our default browser. It says hello, right? And remember what I want you guys to do. If you use the window key right arrow, if I go window key right arrow, it puts it to the right side. And it allows me to put my my Visual Studio Code on the left side. So you kind of see it like side by side, right? And if I want to use, if I want to see the console immediately, you can use, so I click over on the browser, you can use Control-Shift-J, Control-Shift-J, which will bring up my console window, okay? Don't worry about the little arrow. But what you get in the console is something that looks like this, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Okay, excellent. And at the top, you get app started because it starts with app started up here. And 0, 1, 2, 3, 4, 5, 0 to 9, right? Yay, okay. So here's something I want to ask you. If I use the index outside of the for loop, what are the rules for me to use this? Can I do something like index is equal to 15? Can I do that?
No.
Hold on a second. Console log index again. Oops. Let's do a console info. We'll do a console info just to make it different index. So we can say that the console info is going to be different color, right? Because there's also console info. There's console log, console info, console warn, console error, right? You can do a lot of them. And they'll do different colors in the console. All right. So if I go here and I do Control-Shift-J now, right? And and if I press save, notice it's not saved in Visual Studio Code because it's got this little, circle. If I save it, right? All of a sudden we got 15 down here. Wait a minute, what? I shouldn't have 15, right? Because that index should live and die inside the for loop. Nope, because you're using var. It makes global variables. It takes that variable declaration inside of our for loop and hoists it to the top of our file, which means it's available anywhere inside of our code. And my friends, this is terrible. That's why from now on, we do not use var. It will screw you up. It'll give you your code, it'll make your code error prone, potentially. And that's why we, as of ECMAScript 2015, which is what we've talked about, that's why we're talking about this, right? We do not use var anymore. You will see it everywhere out there, right? If you go out to, the industry, you're going to see var everywhere. And quietly start replacing that. Start replacing them with lets, right? And do it, like, obviously test your code. Don't just, because it could be have some other weird side effect. Maybe they want it to do that, right? Some people are weird when they code, right? But if you replace it, you will reduce your errors because what you think you're going to get is what you're going to get. Let's do it again. So let's change this back to let and show you the difference. If I say let, right, then notice this, I get this error that says index is not defined, which is what we should get, right? We should get an index not defined down here because index is dead. Remember, variable scope. The variable lives and dies inside of its curly braces, right? If I make curly braces like this, and because these curly braces belong to the for loop or the if statement, or the whatever, the variable should live and die in those curly braces. If it doesn't, we have a problem. And that's why we don't use var, ever, right? I can't stress it enough. All right, good. So now you understand. Let's get rid of this. This is just an example for us so you understand how it works. Okay, we have some question. Yes, it does mean that. All right, back to this. So that's what functions are. Functions, there's different ways of making functions. And if we think about this, going back to your question again, why an anonymous function? Because we're making a reference to, we're pointing to that anonymous function here with our export default. Our export default points to the function and it returns a reference to that function itself. That's what it does. Another thing about modules is you can import specific things from modules like this, right? Example, I might have not just functions, but I can also export individual variables like so, right? And this is really useful because I could write a variable that I don't export, and that would be a private, quote unquote, private variable for that function, for that module, right? If I don't export this line right here, this thing that I'm doing here, this flag, right? Then it will not be available at all to the thing that I'm importing to. If I was going to use this, kind of a file called validator.js as an example, right? And I want to import flag, it has to be exported. Exporting exposes the variable or function so that I can import it. If I don't export it, I can't import it, even if it exists in the module. Okay, rules that we're talking about here. So these things are the things you should know. And it talks about that. It says, one thing that we know is it returns bindings. When I think about bindings, and if you hear bindings in JavaScript, it means references. That's what bindings mean in JavaScript, references. All right, not values. It doesn't return values. It doesn't care about false. That's not what it's returning. It's returning a reference to the flag variable. That's what it's doing. Okay. All right. So that's modules. Classes, really quickly. Classes, we moved away from prototypes or the prototypal inheritance type, where we have a prototype, kind of a structure. And this is a great segue into what TypeScript has done for us. Let's go to, I'm just going to make this maximized again. So I'm going to go to this. Let's go to typescriptlang.org. Come there. Let's do a tour. Typescriptlang.org. On typescriptlang.org, which we're going to be talking about today, right? We're introducing the TypeScript language, and I'm going to talk about why TypeScript. Why not just program in vanilla JavaScript? People like it, but it's inferior, and I'll talk about why, right? And if you look here, there's something called Playground. Please click on Playground. Under Playground, what you're going to see is an example on the left, right? And I want you to wipe it out. Please wipe it out, whatever the example was on the left. What you're going to get here in the Playground is you can play around with TypeScript on the left, and it'll show you what it emits. Okay, let me say that again. It's going to emit JavaScript on the right. So this is called transpiling. I'm going to take TypeScript and transpile or transcompile. I feel like I said, if you're a Star Trek fan, like I'm transporting, right? Like, from one side or teleporting from one side to the other. That's what it looks like to me, right? So imagine if I want to write a class in ECMAScript, 2015, 2016, 2017. Let's configure TypeScript so it gives us the old code. We're going to go into something called tsconfig. This is in the Playground. There's no risk to you, right? You can do this anytime you want. And what I want you to do is in the Playground, notice it says the language is TypeScript and the target is ECMAScript 2017. That is a version of ECMAScript. Remember, it can always go up to ECMAScript 2022. See that? It has an option. We want to target what I talked about, ECMAScript 5, right? Way back before ES 2015, right? Which was back before that, 2014, 2013. That's the year we're talking about, right? Many years gone. And JSX React, we want to say none, right? And what we may have to do is go back in there, and where it says module pattern, this is the module pattern. I want you to choose CommonJS. All right, that's the CommonJS module pattern. So these are the options: TypeScript, target ES5, JSX none, module connect CommonJS, or we also call CommonJS CJS, right? If I want to target ECMAScript module pattern, it's EJS or ESM is what it's called, actually. Okay, great. That's awesome. Let's close this window. And now let's write a class like you're used to writing it, right? So how do we write it? And you guys have done classes, right? You've done classes? Yes? I'm looking at these guys who are quiet today, right? Yes, no, maybe? So the answer is yes or no? Did you guys write classes or not? Some people say no. Okay, class, what is it? Do you guys know what a class is? Have you guys done C# classes before? Classes are blueprints for objects, right? It's almost like I have a blueprint for building a house, right? Class. So if I did class, I worked the keyword class, right? Hold on, take a look at the right there. Just by working my magic here and saying class, right? And then I want to call it the class, the person class, right? And the person class, right? We're going to define the person class. It's going to have a constructor function, right? And the constructor function is going to take things like name and age, right? So I might have something like this. I might have a name, which is a string. That can be explicit, and age, which is a number. Okay. Here's my constructor function, right? And maybe I have some private instance members, Let's see if I can make this bigger, this window, so you guys can see it a little bigger. There we go. I like to make mine bigger so you can see it. So let's say I have here, I have an area that I have private instance members, right? These private instance members belong to the class itself. So I might have something like a private member called m_name, which is also a string, right? And I also have a private member called m_age, which is also a number, right? And notice it says m_name and m_age. It has a problem with that, doesn't like those. And inside my constructor function, you may see something like this in other languages where I do something like this dot m_name is equal to name. And this dot m_age is equal to age. And what we're doing here with this function is I'm assigning the stuff that we put into our constructor function, the parameters. We're assigning their values to the private instance members, which are also called fields. Okay. Is this something that is familiar? Okay. Well, now you know. So look at the right. That's the old way of writing a class. And what do you see here that should stand out to you when you see it for the first time? What do you see here? Uses var, but what's the other thing that you can see here that's really should stand out to you? We've kind of talked about this last week. There's a structure that you see here. Let someone else answer. See if they can come up with the two, right? What do you think? Can anyone identify a structure that you see on the right that we actually included in our files? How about you guys over there? I can walk around. Yeah, I'm not limited to my chair. I can go over there, right? Come on, take a look. Look at what we're seeing here on the side. What's this? What do we have here? Right here. What is this? Yes. What? Anonymous function, also known as mentioned this last time. An IFE, an immediately invoked function expression. We did that here in our Visual Studio Code. Take a look. In our Visual Studio Code, there it is. Look, that thing right here. It's right here, right? Yes, yes. It's the IFE, right? And the IFE, if you think about it, this IFE was used all the time to construct classes in the past. My friends, it doesn't matter how fancy your class looks here in ECMAScript 2015, 2016, 2017. Underlying everything, it looks ugly like this. Exactly like that. Nothing you can do about it. It doesn't matter if I make these things private or not. There are no variables that are private when we create stuff in JavaScript. It's just for us. So TypeScript is not going to change JavaScript. What TypeScript does is it gives us tooling so we can identify errors in our code or our style, right? We never ever want to, redefine a variable from an integer or a number to a string. We never really want to do that ever. That is dumb to do. We want to keep variables, whatever we declare them is how they're going to stay from a data type perspective. In JavaScript doesn't care. It'll allow you to declare anything as anything. I can make a variable a function, and I can turn around, I can make it a string and follow it up with an integer, right? Doesn't matter. That's why JavaScript is hard, because people are like, well, you made it here an array, and then you changed it to a function, and changed it to a string, you went to a number. It's the same name that they use the entire way. And some developers would be like, haha, it's so elegant. No, it's really ugly and dumb. Why would you do something like that? That is a terrible thing to do, right? And so JavaScript doesn't like that, or TypeScript doesn't like that. So that's one. This is a constructor function, so that you can make more than one constructor signature. Right here, we're just having, so this is constructor. In JavaScript, there is no explicit destructor, right? You might have a destructor that's available to you in C# or C++, in Java, in other languages here, no, right? And then we also have methods, right? Methods are public or private functions. Let's make it a public method, public. And the way you do it is you call the method name whatever it's going to be. You don't use the function keyword when you make your classes at all. You just call it whatever it's going to be. And you say, for example, I don't know, says hello, right? You can also specify its return type. in this case, void, right? So this private method, public method, which just says hello, right? You can make it do something like you can output the name of the person that you're constructing. For example, console log. And instead of using quotations, we can use something called a template string. Template strings were introduced in ECMAScript 2015 as well. Template strings start with the backtick character. I mentioned this last week. Use the backtick character, and then what you can do is I want to inject, right? I want to inject code. I can use this.m_name, right? And it will inject the name inside the string itself. I don't have to do concatenation, all right? So I can say it says hello, right? And we always want to end things off with a semicolon. However, JavaScript does not require them. Yeah, it doesn't require semicolons. And that makes me very nervous. You might see places up on the web, even frameworks that don't use semicolons. Guys, I still encourage you to use them because it's a real clear delineation of when your command is over, when it finishes, when it completes, right? Now, take a look at the side. Here's the functional method. This is a method, prototypal, method. What it does is it says person.prototype. So here's the person class. Person.prototype says hello is equal to a function, right? Going back to what you asked. This is how functions were, or class functions were created back in the day. Yes. Yes. Here, static functions would look like this. Let's say, for example, static functions were, I had a public static function that was something like, I don't know, calculate. And you had, I don't know, some kind of, A, which is a number, and B, which is another number. And let's say you added them together. And let's say this whole function returned a number, right? Then what you can say is that, let's not call it calculate, let's call it add or sum. How about that? Sum function, right? And we'll say I'm just making this up because you asked. I can return, A plus B, right? I can do that. And now you can see what it does. It kind of adds sum as part of the person itself. It doesn't add it to the prototype, which means you don't have to instantiate an object of type person in order for you to use the static sum function. You can just go person.sum and then use it. You can use it as a class function as opposed to an object function. Whew. Questions around this? So left, beautiful JavaScript. It looks nice. Beautiful code, period, the end, right? I can code nicely with the left. On the right, ugly ECMAScript 5, right? This is how we used to write it. And some people still love it this way. They love it the other way. They love it the other way. By the way, could you code this way right now? The answer is absolutely. You can still code this way right now. You can still use the old functional, class-based thing that you want to do. So this is where we have a problem now. Class person is in the wild. Class person is in the public namespace, right? Or the global namespace. And one thing that TypeScript does that ECMAScript does not do, right, at all, is JavaScript JavaScript does not provide a namespace. It provides modules, but not namespaces. Namespaces are an additional, protection for the class itself. So what I can do with TypeScript is do something like this. I can say my namespace, right, as an example, might be something like objects, right? And inside my namespace objects, I'm going to put the class person inside there, right? So I'm going to take this whole class person, right? And I'm going to cut it. I'm going to put it inside my namespace. And what it does is if you put something inside of a namespace and you don't export it, just like a module, it will be unavailable. Now, this is interesting. Take a look at the syntax on the right, because this is really what's happening. So I have an iffy, and I have another iffy inside of it. I have an iffy within an iffy, right? This is how it was done back in the day. Actually, it's still done this way today. If I want to create a namespace, I need to make layers of iffies, right? Which is layers of closures. I'm putting my functions in jail twice, right? So the first part of jail for the function would be the class. The class is its own jail or container, if you think about it, right? And then out of that, I have another external wall, which is my namespace. Okay, so that's the namespace itself. And if I leave it like this, class person is unavailable outside of this iffy, right? If I want to make it available, I need to export it. And when I do that now, at the bottom, you can see that I have this really funky syntax where I attach person to the object's namespace. Now, if you are confused, right, and you may be confused, or you may look at this and go, but Tom, why are you showing this stuff? Because I need you to understand that this is happening on the right side, no matter what you do on the left side. No matter what you do in ECMAScript 2015, 2016, even the brand new JavaScript is still doing this on the underlying, code. It's recoding it for you. It's just making it nice for you, right? That's all it's doing. Okay. Let's shift for a second and let me show you what it looks like in modern JavaScript. This is old JavaScript, ECMAScript 5. Let's retarget. So again, going up to here on the left, right? Remember, we have access to go into tsconfig, and let's change our target from ECMAScript 5 to ECMAScript 2022, a new one. All right, it just came out in June. Now, if I do this, you'll see that, well, there's not a lot of changes, right? There's not a lot of differences between the two, except there are no private variables. You can't do that anymore. Even now, in the most modern JavaScript, you can't do that, okay? And there is no namespace. It doesn't exist. You still need to use this iffy at the outside. Modern JavaScript requires it, okay? You have no choice. If you want to encapsulate your class and hide it from the rest of the world and only expose it when you need to put it in an iffy. And that's why day one, we did an iffy together last week, because you need it. You need to understand how to do that, right? If you don't want your stuff, your sensitive code being exposed to the world, not that they can't change it, you would need someone who knows what to do for them to do that. You're good to go. Otherwise, if I don't put it there, I can go to the command line on a browser and literally type in person is equal to a new person. That's how it can be done. All right. It's like expose. Does this make sense? So this is what you really get, right? Even in the most modern JavaScript. And this is what you get with TypeScript. And this is why we want TypeScript. TypeScript provides us with tooling. TypeScript provides us with support. However, there's a hiccup. You need to transpile because browsers do not understand TypeScript yet. They only understand JavaScript, which means we need to convert our TypeScript file to a JavaScript file, and we need, just like we have here, a tsconfig.json file, which we're going to configure later on, as well as the ability for us to transpile, which is built into Visual Studio Code. Questions around classes? I didn't go through the PowerPoint, sorry. I showed you how to do it, right? So you understand what I'm talking about, right? The playground is super useful if you want to do an experiment, right? You try something on the left and it produces the JavaScript, pure JavaScript on the right, right? That will work in every browser. Notice also that on the right-hand side, there are no vars, except for this one, right? And it's okay because it's at the top end of it, right? That's the only time. I'm saying to you, don't you use vars. If it transpiles to a var, oh, that's not to you, that's not up to you. That's the TypeScript compiler, right? Yes. 2022. We're always going to use the latest version. Why not? It's our code. We can do whatever we want, right? Okay, let's move on from here because we should probably take a break soon. So we talked about classes and what they are. I gave you an example of vehicles. You can also use the extends keyword. It's kind of hard to see here, but you can always use the extends keyword to inherit from the vehicle superclass, just like you would in other languages. And remember also when we think about classes, just as an OOP review, if I was going to ask you, what's fatter, right, in real life? Children or parents? Definitely, typically. Are the parents fatter in real life or are the children fatter in real life? Real life. Children. Are they fatter or are the parents fatter? The parents are fatter, right? I'm fatter than my boys, that's for sure, right? My boys are like, they got a VBAC, they're crazy. They work out all the time. I don't do that, right? I'm fatter than they are. Not so in programming. In programming, all the children are always fatter than the parents. Why? I want you to remember it this way. That's why I'm saying it just like this. I want you to remember it, right? Why are the children always fatter than the parents in programming when it comes to OOP? They inherit everything from the parent and they specialize, which means they add more stuff, which means their memory footprint is bigger, right? If their memory footprint is bigger, they are fatter. Simple as that. That means inheritance can have a problem. Here's what I'm saying. It's if you create an inheritance hierarchy, or we like to call it an inheritance chain, right? And if I keep inheriting, the classes get fatter and fatter and fatter and fatter and fatter, and people hate that stuff. They compare it to other sicknesses in real life. They're like, that is just not right, man. That is sick code you got there. You gotta remedy it. Something's wrong, right? Because inheritance is not the only way we can code. We can also use something called composition, right? And composition is better because we don't need to inherit stuff. We just plug in the objects we need inside of our classes, as opposed to inherit. Inheritance is super bad when it comes to something that you want to do multiple times every second. Example, if I'm coding a game, right? We're playing games and I want to use some kind of enemies. Let's suppose I want to use particle systems for the enemies where it looks like smoke, right? Each particle system is a point in space. If that particle system is inheriting from a game object, right? Which means it has a transform like position, rotation, and scale. It has some kind of renderer. It has a bunch of other stuff that every other game object has, right? It's going to be super fat. So I'm going to have this little particle that looks like a dot on the screen, and it's going to be like taking as much memory as my alien that runs around, right? Inheritance. We don't want to use it like that. If it's something that's running every frame, example, 60 times every second, it's computationally expensive to do something every second. We don't want to do that. So there's places to use inheritance. For example, when we write our applications, it's okay, right? We're not going to run something every frame, typically, right? But it's really bad when we do something, multiple times per second. All right, so that is a very high-level overview of OOP. Right? You guys should know more about that from your other courses, your C# classes, as well as other classes that you're going to be taking with Rich and myself. Arrow functions we talked about. We talked about what this lexical this does to the scope. We talked about that as well. And I'm just going to skip through here. I talked about one other thing. There's something called object notation in JavaScript. Did you guys learn about this? Okay, good. Object notation, there's a bunch of ways to write an object. I can write an object like this here on the left, where I can say I have these curly braces and I can do this, where my author, I just kind of use curly braces to describe the object. And this is kind of like a live object that doesn't even have a class. So a classless object, I can make that in JavaScript. It doesn't exist in any other language. Can't do that. But in JavaScript, you can. And I think that's really powerful. You can do that. But it's also really dangerous because you can define whatever you want, right? The other way to do it is this. You make a new object instead. Start off with a new object. The capital O object does exist in JavaScript, and you can create an empty container, right? And then this is a rule that I want you to learn. If you define it, you create it in JavaScript. So if, for example, the property full name or never existed until I started using it. As soon as I use it, JavaScript allocates memory for it. It's kind of a weird way of doing stuff. Whereas I don't need to use the let keyword or const to define a property when I use object notation. As once I attach something in JavaScript, it creates it. TypeScript is not like this. TypeScript will complain. It'll make everything underlined saying, what the heck is this? You haven't defined any kind of blueprint for this class. And you're adding stuff like a property. You didn't tell me anything about this, Tom, right? I'm really mad at you. I'm going to put red lines everywhere, right? And I'm okay with that because it's telling me there's another way to do this. There's probably a better way to do this. There's something that's more human readable because object notation, although it's powerful, sometimes can be unreadable by humans. We'll look at it and go like, what the hell is going on here, right? And you're going to see people's code. This is what this class is about. You're going to see people's code base. We're going to make a code base. And today you're like, I only got like one function and start, right? And it's okay. But I challenge you to look at your code base, at the end of the course and see what it looks like. And ask yourself this question, if I gave your code base at the end of the course today, could you understand what you were doing? And you probably would say, I have no idea what's going on here, right? Because there's so much stuff we're going to add from now until then, right? So this is what we want to avoid. Object notation is great, and there's different ways of doing it, but we want to avoid. We talked about closures, functions within functions, and the scope. That's all stuff that is included in ECMAScript 2015, 2016, 2017. Questions around ECMAScript. That is a very brief review of everything you should have known last semester, or the time you took JavaScript, right? And if you do not know these things, there are plenty of resources out there to help you. There's some great courses on LinkedIn Learning that I recommend you take a look at. You know, this is what I'm giving you is JavaScript, the good parts, you know, kind of thing. Only the parts you need. There are a ton more stuff that we can go through, and I would never finish. I could talk all day long about structures of JavaScript and never do one piece of code, right? It's that's how deep it is. All right, we're sitting at 9:30, and before I get into AJAX and what the heck that is, let's take a short break. Let's take 10 minutes. We'll come back at 9:40, and then we'll finish it off with AJAX, a little bit of TypeScript, and get you guys going for your in-class exercise number 2. Okay.